Hello, this video will deal with the Nobel Prize in Chemistry from 1912, awarded to Victor Grignard for the discovery of the Grignard reagent, and to Paul Sabatier for his method of hydrogenating organic compounds in the presence of finely disintegrated metals. Two different reasons thus, they didn't cooperate. First you see an example of the Grignard reaction, about which later more, of course. You see here a double-binded oxygen molecule with R2 and R3, which could be hydrogen or another substance atom. And you see that it is a two-step reaction. Now, more about that later. The work he did, coming from the official Nobel Prize site, more explanation why he got the prize. Nature is full of organic substances, a large and varied quantity of chemical compounds that contain the element carbon. Combining, synthesizing organic substances by chemical means is important in both scientific and industrial contexts. In 1900, Victor Grignard developed a method for combining more basic organic compounds into more complex ones by causing carbon atoms to be bound to one another. The method uses magnesium as a reagent, a substance that activates the process. Here you see the magnesium. Okay. Then some biographical information also coming from the Nobel Prize sites, summarized by me. It's not a complete taken over. Tertiary alcohols. The Grignard's first investigations concerned ethyl-bay isopropylaceobutyrate and the stereoisomeric diisopropylbutyrate acids. That's quite a mouthful. And studied the branched unsaturated hydrocarbons. In 1899, on Barber's recommendation, he studied organomagnesium compounds, and his discovery of the classic preparation of magnesium alkylates was first communicated by Henri Moissan to the Académie des Sciences on May 11, 1900. He quickly developed the immediate application of these elegant and simple reagents, which were destined to play such an important role in organic synthesis at the time of his death in 1935. There were over 6,000 references to him in the literature. He used the agents to prepare and study the more exotic alcohols, ketones, ketoesters, nitriles, and terpene compounds, and he developed a method for the synthesis of fulvenes. He also been concerned with work on the constitution of unsaturated compounds by quantitative ozonation, condensation of aldehydes, and ketones, splitting of cracking of hydrocarbons in the presence of aluminium fluoride, and catalytic hydrogenation and dehydrogenation processes under reduced pressure. Grignard was the author of some 170 publications on this research, and at his death he was working to fulfill his ambition to see a great chemical reference work in the French language. 2 volumes of Traite de chimie organique, treatise on organic chemistry, had already been published. 2 more were ready for the press, and editorial work for another 2 was well advanced. It was later to be finished by his collaborators. In 1937, 2 of his students, Jean Colonne and Roger Grignard, published Précis de chimie organique, Survey of Organic Chemistry, which is based on lectures in organic chemistry by Grignard, of course. But that was his son. Look it up sometime. You see some additional reactions which involve Grignard reagents, but are considered the Grignard reaction proper. See, it's derivatives of his original work, of course. Here we go to the other laureate, Sabatier. This is his office desk at the University of Toulouse, as you can see. And some of the chemicals. What did he do? Again, from the Nobel Prize site, nature is full of organic substances, a large and varied quantity of chemical compounds that contain the element carbon. Combining, synthesizing organic substances by chemical means is important in both scientific and industrial contexts. We had it before with the other laureate. Around 1897, now it changes, Paul Sabatier developed a method for causing unsaturated organic substances to absorb hydrogen and form new organic compounds. The method primarily uses nickel, but also other metals as catalysts, substances that facilitate the process without being integrated into the final product. There's some biographical information also from the Nobel Prize side and summarized by me. Sabatier's earliest research concerned the thermochemistry of sulfur and metallic sulfates, the subject for his thesis leading to his doctorate, and in Toulouse he continued his physical-chemical investigations to sulfides, chlorides, chromates, and copper compounds. He also studied the oxides of nitrogen and disulfonic acid and its salts and carried out fundamental research on partition coefficients and absorption spectra. When he started his investigations into the phenomenon of catalysis, Sabatier soon pointed out anomalies in Faraday's physical theory, and he in turn formulated his chemical theory which postulated the formation of unstable intermediaries. His subsequent painstaking work and discovery of the use of finely divided metal hydrogenation catalysts subsequently formed the basis of the margarine, oil, hydrogenation, and synthetic methanol industries. He demonstrated the selectivity of catalytic action and also the selectivity of catalysts to poisons, as well as introducing the use of supports and showing the resultant enhanced activity. He also made a close study of catalytic hydrogenation and dehydrogenation, examining carefully the feasibility of specific reactions and the general activity of various catalysts. Sabatier's work is accurately recorded in the publications of learned societies, and his important book, La catalyse en chimie organique, Catalysis in Organic Chemistry, was first published in 1913, with a second edition in 1920, of which an English translation by E. Reed was published in 1923. Here an illustration of one of the things Sabatier did, in this case it's electrolysis. If you want to study it, pause the video or go to the original source. Then some more information coming also from the Nobel Prize side, of course, the speed read creating carbon connections. Again summarized by me. During a meticulous analysis of the way in which a set of chemicals interacts with metals, Victor Grignard devised a new method of coupling together a carbon atom from one molecule onto a carbon atom from another. The key was to carry out a particular reaction he was investigating in two separate steps. In the first step, an organohalide compound, which contains a carbon atom attached to a halogen atom, like chlorine, bromine, or iodine, combines with a magnesium in the presence of ether. And in the second step, another carbon-containing compound is added to the mix. As it turns out, the intermediate compound that magnesium forms with the organohalide during the first step is extremely receptive to a large number of carbon compounds, attaching a carbon atom onto its own carbon and releasing magnesium in the process. With its wide application, which was named Grignard reagent, after its discoverer, quickly became an indispensable means for the chemists looking to stitch together smaller precursor molecules to create organic compounds. Paul Sabatier's interest in catalytic reactions in organic chemistry led him becoming the first chemist to detail the advantage of using nickel to drive reactions with organic compounds. He showed how hydrogen atoms can be linked with atoms in a range of carbon compounds by passing a mixture of both over finely powdered nickel at a high temperature. In this situation, nickel serves momentarily as a carrier for hydrogen and enables it to transfer it onto a carbon atom. A simple, safe, and convenient method, this hydrogenation process formed the basis of many laboratory reactions and important industrial processes, chief among them being conversion of liquid oils into solid fats, the process behind the production of margarine. Here you can see the link to the original source. And finally, in this video, the award ceremony speech by Professor A.G. Söderbaum, explaining why the prize were awarded. The methods in respect of which the awards were made both belong to the field of organic chemical synthesis, the purpose of which is the artificial production of organic compounds, that is, derivative with carbon as a basic element, whether or not such derivatives are found in that exact form in the animal or vegetable kingdom. This branch of chemistry is fairly young. It is usually considered to date from a discovery made in 1828 by Friedrich Wöhler, a disciple of Berzelius. From this humble beginning, from one isolated observation, organic synthesis has developed, especially during the last half century, into something of an undreamed of importance, not only for the science of chemistry itself, but also for the application of chemistry to everyday life. It's certainly no exaggeration to say that those branches of industry which are based on the use of synthetic methods in organic chemistry have provided a livelihood for millions of men and have created wealth to the value of thousands of millions of pounds. For this reason, discoveries opening the way to new developments in this sphere can be said to have conferred to the greatest benefit of mankind, irrespective of whether these words are taken in a wider sense or a limited, not to say literal sense. Professor Grignard's method is the culmination of a series of investigations carried out with remarkable technical skill, which revealed that metallic magnesium in the presence of ether reacts on organic derivatives of chlorine, bromine, and iodine by forming ether-soluble organic compounds of magnesium. These latter compounds in turn react extremely readily with a large number of other organic substances, so that carbon combines with carbon in forming true organic synthesis. The importance of Grignard's method to organic chemistry lies in the number of essential virtues that it possesses, namely simplicity of procedure and therefore saving of time, low cost of materials employed, satisfactory yield, and most important of all, a very light application. From this last point of view, no method of organic synthesis superior to that of Grignard is known, and indeed there is scarcely any sphere of organic chemistry outside its scope. The services which this method has rendered to science are great, but no less great are those which it can be expected to render in the future. Shall we, for instance, ever learn how to produce artificial alkaloids of physical organic bases, which are so important in medicine, but which still so difficult to prepare and therefore so costly? If we do, there's little doubt that it will only be with the aid of Grignard's reagent. Professor Grignard, anyone who has been concerned with organic chemistry during recent years knows how greatly you have contributed to the advancement of this branch of science. The number of remarkable and important investigations which have been made possible by the reagent invented by you and named after you is already most imposing, and it continues to increase every day. Your method has thus pushed back appreciably the frontiers of our knowledge, of our ability to observe, and not only that, it's also opening prospects of a new conquest for our science. Okay, the new method, which has been named after its inventor, Professor Sabatier, consists of reduction of organic compounds under the action of finely powdered metals, nickel, cobalt, copper, iron, or platinum. This method is as follows. An oxide of one of these metals is heated to around 300 degrees Celsius in a current of hydrogen gas. After the metal has been reduced in this way, the heat is decreased and vapor of the organic substance which has to be reduced is mixed with the hydrogen gas. The method is very simple and convenient, and its yield is high. In addition to these advantages, it is completely safe, which happily distinguishes it from the reaction method, hitherto most widely used, which all too often gives rise to explosions, some of them very serious. Sabatier's reduction method has been very extensively employed, not only by its inventor and its disciples, and it had opened up new fields of scientific research. It also rendered services to many scientists in various countries and has enabled them to obtain important results which would have been impossible with the old method. Moreover, several chemists have introduced various modifications for different purposes, and this has considerably increased the range of its uses. Among the most interesting results obtained by Sabatier's method, I will confine myself to recalling how Professor Sabatier, by applying under various experimental conditions, as reagent to the hydrogen carbide, acetylene, succeeded in producing higher homologues of hydrocarbons identical with those contained in natural petroleum of different origins. For instance, American, Russian, or Galician, upon which phenomenon he based a general theory for explaining the origin of different mineral oils. Professor Sabatier, in one of your works, which I have been familiar for several years, you say that in the study of the phenomena of the physical world, no matter what these phenomena may be, the basis of any system must be observation, precise, strict, and free from all preconceptions. These are memorable words, which to many seem a truism, though the message they contain frequently goes unheeded. They cannot therefore be repeated too often. You, sir, have not merely professed this doctrine in your books, you have applied it throughout your scientific career. Thanks to this constant application of your principles, you have achieved results whose value, and this we can say with certainty, will always remain. For me, it's most gratifying duty to congratulate you on behalf of the Royal Swedish Academy of Science upon your brilliant scientific achievements, and in particular your general method of hydrogenating organic compounds in the presence of reduced metals and catalysts, a method which in the sphere of organic chemistry has during the past few years made possible much progress and opening up of so many new fields of science. Okay, this is a summary of the award ceremony speech. If you want to read the complete speech, then you have to follow this link to the official Nobel Prize site. Here again you see the Grignard reagent, which has passed by several times in the last 50 minutes or so. Next week we will deal with the Nobel Prize lectures given by Grignard and by Sabatier in a new movie. For now, thank you for watching and maybe see you another time.